Dear students, so far we have completed 3 units. Unit number 1 introduction, unit number 2 measures of central tendency and dispersion, and unit number 3 measures of relation. Now today I am going to teach unit number 4, that is set theory. Set theory. This comes under mathematical part, particularly pure maths part. Sets are defined as the collection of objects whose elements are fixed and cannot be changed. Set means 2 or more items, collection of objects whose elements are fixed. That means we cannot change the elements in a set. A set is well defined as a collection of data that does not carry from person to person. That means it doesn't differ from one person to another. That the elements in the set cannot be repeated but can be written in any order. And likewise ascending order, descending order, or even in a irregular order. Most of the sets are represented by capital letters. A is equal to B is equal to C is equal to, like that. Next, coming to types of sets, number 1 is empty set, where there are no elements or nil elements, then it is called as a empty set. That means in that set there are no elements. Second one is singleton set. If there is only one element in a particular set, the set which has only one element is named as singleton set. The third one, we got 2 items. One is finite and the other is infinite. A set that has a finite number of elements is known as a finite set, whereas the set whose elements cannot be estimated but has some figures. Here we have to understand, infinite set means there are elements but there are infinite elements, which is large to precise in a set. For example, A is equal to 1, 2, 3, 4, 5 is a finite set, whereas A is equal to number of cows in India. For example, number of cows in India. We cannot count them. We cannot exactly count them. This is called as infinite set. Next one is equal sets. That means if 2 sets A and B has the same elements, that means if every element of set A is also the element of set B, and if every element of set B is also the element of set A, then set A and B are called equal sets. That means we generally denote it as A equal to B. However, here one should understand that the elements should not be in a similar order. That means elements in A must be equal to elements in B. For example, if A is equal to 3, 4, 5, 6 and B can be 6, 5, 4, 3. This is in ascending order, that is in descending order. However, both the elements in A and B are equal. Then we can say it as A is equal to B. Next one, universal set. A set that contains all the elements of the given sets. For example, there may be 2 sets, 3, 4, 5. If each and every element are in a particular set, it is called as universal set. It is generally denoted with the capital letter U. Capital letter U. Next, coming to Venn diagrams. We can just look into this diagram before I explain. These are Venn diagrams, generally in a circle. Generally in a circle. It can be shown in square or hexagon, but generally it will be in the form of a circle. Venn diagram are introduced by John Venn. Generally he uses circles to denote the relationship between 2 sets. For example, if you observe, A and B are in the first diagram, A, B and C are in the second diagram. Here, if you observe, the overlapping area is called as intersection. If you observe, That means A intersection B is the overlapping of A and B. Next, let us move on to what is Venn diagram. Venn diagrams that are used to represent the sets, relation between the sets and operation performed on them. In the next slide, we will know various operations used in set. Venn diagrams was introduced by John Venn. Generally he uses circles. A Venn diagram is also called a set diagram or a logic diagram showing different set operations such as intersection, union and difference of sets. A intersection B, A union B and A minus B are the three operations generally we use in sets. A diagram used to represent all possible relations of different sets is called a Venn diagram. Generally, Venn diagram is a closed figure, a circle, polygon, square, hexagon. But generally, we use circles to represent each and every set. Next, how to draw these Venn diagrams? Means, first of all, you have to set the parameters of your analysis. How to create or how to draw Venn diagrams. First, determine what your goal is, in such as making an important decision or understanding complex topics. Next, determine how many concepts or sets of ideas. I have already shown you two diagrams. In one diagram there are only A and B, in the other diagram there are A, B and C. Then determine the type of Venn diagram to make by establishing how you want to show each set's relationship with each other, how much they intersect with each other, like that. Next, you have to create an area. This area is called as universe. Generally, a rectangle in which all the other shapes will sit. For example, if you take a rectangle, make sure that other shapes overlap so that you can find possible relationships among the sets. Next, label all your sets. Next, A, B, like that labeling. You should represent simple or simplified ideas that pertain to all the data in each set. For example, if you were comparing two characteristics, you would use characters' names to identify them. Generally, you have roll numbers in your class. Register numbers write in the examinations. For what these are indicated? To indicate a particular student in a particular class. Your number represents in which group you are studying, in which group, in which year you have started. Likewise. Next, place the data in the Venn diagram as shown. Then you can, mere looking into the Venn diagram, you can easily analyze. If you observe, there are in the second diagram, there are overlapping between A and B, A and C, B and C, and A, B and C. If you observe, the overlapping area of A and B is called A intersection B, A and C is called A intersection C, B and C is called B intersection C. And the overlapping of A, B and C is called A intersection, B intersection C. This is Venn diagram. However, we have already discussed about different types of sets. Number one is union of sets. That means if two sets A and B are given, then the union of A and B is equal to the set that contains all the elements present in A and B. If only there are A and B sets, union, we have already learnt types of sets. Universal set. Universal set is nothing but union. Next one is intersection. If two sets A and B are given, then the intersection of A and B consists of elements common to both A and B. And that means the elements in A must be in elements in B. The elements in B must be an element in A, in set A. If both A and B have common elements, that common elements are nothing but A intersection B. Difference means two sets A and B, then the difference of two sets A and B is equal to the set which consists of elements in A but not in B. Here you have to observe that A minus B is not equal to B minus A. That means only those elements present in A but not in B are represented as A minus B. Therefore, there are three types of sets. One is operations of sets, one is union of sets, second one is intersection of sets, and the third one is difference of sets. This is the end of Unit 4. Then in the next we will come across or we learn about the last unit, that is Unit 5. Thank you.